In this video, we are going to be working on solving simple equations by making use of one basic principle. The main thing to remember when solving equations is that whatever you do to one side of an equation, you must also do to the other side. As long as we follow this rule, we can do as many operations as necessary to solve an equation. Here we want to solve the equation 7m plus 10 is equal to negative 6 minus m. In order to solve this, we first want to have all of the terms involving an m on one side of the equation and all of the terms which are numbers on the other side of the equation. Here we're going to choose to move the terms containing an m to the left side of the equation and the numbers to the right side. In order to get rid of the negative m on the right side of the equation, you need to do the opposite operation of subtracting, which means you need to add an m. Whatever you do to one side of the equation must also be done to the other side, so you must add m to both sides of the equation. On the right side, m subtract m is equal to 0, so we have eliminated m from the right side. Then you want to eliminate the positive 10 from the left side of the equation, so you need to do the opposite of adding 10 by subtracting 10 from both sides of the equation. On the left side, 10 subtract 10 is equal to 0, so we have eliminated 10 from the left side of the equation. Then, combine like terms on each side of the equation. On the left side, add the coefficients of the m's to get that 7m plus m is equal to 8m, and on the right side, compute negative 6 subtract 10, which is equal to negative 16. Now the m, which we are trying to solve for, is being multiplied by 8. So in order to get the m by itself, we need to divide both sides of the equation by 8. This works nicely because on the left side of the equation, 8m divided by 8 is equal to m, so we finally have m by itself. On the right side of the equation, negative 16 divided by 8 is equal to negative 2. Thus we have found that the solution to this equation is m equal to negative 2. Now we remember that in the standard form of a trinomial, we have ax squared plus bx plus c.
We explain how Archimedes chose pi from perimetros, meaning perimeter, when determining the circumference of a circle. But what Archimedes used pi to represent wasn't the constant 3.14159 we know it as today.